All right, welcome back to the Unreal Engine Workshop in the winter 2026 timeframe here at Georgian. And where last we left off, we were talking about our viewport, and I asked you guys as a bit of a challenge to create a little wall or do some manipulation inside of a viewport, and I see some of you have done that. Thank you. So as you can see, now that you've done this, you know how to manipulate and scale objects, and you actually can play the game with the stuff you've created. So if I actually run this thing, you can see that now the wall is here. I can't go through it, and this is the wall that I made very, very simply. And Quinn can still run around and jump on top of stuff and do everything that she did before. Awesome. So that's what we did, and I know a lot of you were way more creative than me and brought some stuff in from Fab and did a lot of stuff. That's really great. So what I want to do next is do a little bit more of, that's what we did just now. I want to do some work with blueprints. So the one thing I want to talk about is blueprints and what are they. I talked about them as visual scripting, with blueprint logic. What I want to do with this little example here is I want to make a spinning cube, all right, with blueprints. I want to make that cube spin, right? So how do we do that? So let's pick a cube as an example. So this is the kind of cube that I want to spin. And you'd be forgiven to think that you can just do it here. Can't do it. You have to make another object. And so for this, on the left here, you can see we're in the content drawer. If you click on the content folder, this is where we actually do the real work. If your tabs are too small, your folder is too small, you can kind of control and use your mouse wheel to scroll in and out. You can make these folders larger or smaller if you don't like how they're laid out. I'm going to make them big so you can see them on the screen. And what I want to do is I want to right click here in the content folder and make a new folder. Let's do that. So new folder, and we'll call this new folder blueprints. Okay, there we go. We're going to do this a couple times today, just so you guys get used to it, right? And inside the blueprints folder, I want to just double click on that folder now. Inside this blueprints folder, I want to make a brand new blueprint. Okay, we'll talk about what this thing is, right? So to do this, right click, right? And you have this little context menu. By the way, there's multiple ways to do what I just did. You don't have to right click. You can add a blueprint in different ways, but right clicking is definitely the fastest way. So right click will bring up this little context sensitive menu. We want to click on blueprint class. That's the one we want. Okay, so right click blueprint class. When you do that, it'll pull up this, kind of a bunch of these options in this dialog box. I call this a dialog box, right? And what we want to choose is actor. I want to choose the actor class. All right, and I want to name this blueprint. And by the way, in Unreal Engine, the naming conventions are the following. If I'm making a blueprint, we start them like this: BP for blueprint underscore, and whatever the name of the blueprint is. In our case, cube. BP underscore cube, like so. Okay. And there's conventions we're going to talk about all day. So, some people don't like to follow them, even creators. That's fine. So this BP underscore cube looks like nothing right now. It just looks like this sphere. So before we move on, are you all with me?
Yep.
Yes.
With the naming conventions, does it link spaces or no?
No spaces.
Okay.
Because it's like anything else. When we're programming, you can't have spaces in your variable names.
I know students are going to make that mistake, so this one.
Yeah. Definitely no spaces. All right, so I know special weird characters. Try and avoid like exclamation marks and hashtags and stuff like that. Keep to the underscore, that's okay. Let's double click on this blueprint. When you double click, because we changed our settings for our editor, remember we did that editor setting change earlier? It'll put it in the main window. But if you have it down here like this, that means that you didn't do what I asked you to do, which is you have to go to edit. And if I go to editor preferences, please remember to do this. You have to change your asset editor open location to main window, and then that'll do that. Okay, so edit, if you go to edit menu, and then editor preferences, right? However, if you did do that, you should see your cube blueprint come up here. Let's talk about the anatomy of a blueprint for a second, okay? Here's the anatomy of a blueprint. It looks very complex, but actually it's quite simple, all right? On the right, you see the details panel for anything that you're looking at on the left. On the left, it's almost like a little tiny world outliner, but it's only for your blueprint, all right? So in here, we have the name of the blueprint, BP underscore cube. That's why it says self. And there's something called a default scene root. The default scene root, I want you to think about it as an empty object. So in Unity, if you're a Unity person, it'd be just like an empty object. Or in Blender, it's an empty. That's all it is. It's just an empty object with a transform. That's all it is, okay? This is no good for us. We want to add in a cube. And to do that, we need to add in a static mesh. So the way to add components on the left-hand side is you click the Add button over here on the Components tab, and then we can add in a static mesh. You can search for it here, static, and notice that static mesh comes up. Okay, static mesh. So we can rename this to cube mesh if you want to. Instead of just taking static mesh, we can rename it. If you didn't do that, you can always change the name on the right-hand side. Notice on the right-hand side, there's a variable name. Remember, it's a variable name, so it follows variable conventions. You cannot use spaces. You cannot use special characters. Just use, but you could use an underscore if you really want to. Okay? So cube mesh is what we want to add in here, if that makes sense. The cube mesh has, a lot of other objects. I want you to think about any component we add in here in the Components tab. Yes? What happened?
It goes to the menu and the screen goes black.
It's a lovely thing with Unreal Engine. You may have to relaunch your Unreal Engine. Oh, you mean the whole screen is black?
The whole thing. Yeah.
Woohoo! Oh, you broke it. That's great.
Technology.
This is what it looks like.
Love it.
I guess when I go over there.
But before we continue, has everyone got the cube mesh like this? Okay, so I've added a static mesh, but I want you to think about this component as a container. Even though it says cube mesh, there's no cube in it right now. We have to, kind of manipulate the container to tell it where to look for our cube mesh, right? On the right, I want to go over this again. Every object you add in has a transform, a location, a rotation, and a scale. And by default, if I look at the anatomy of a blueprint, every blueprint has the following tabs: the viewport tab, the construction script, and the event graph. Those three tabs at the top here, right? So the viewport tab is very important because this is what your object is going to look like when you bring it into the game. Right now, it looks like nothing because there's nothing in here, all right? So what we want to do is when we click on the cube mesh, on the right-hand side, there is a static mesh kind of property right here. See the static mesh property? We can pull down our cube. Let's look for it by doing, just in the search field, we can put in SM_cube, and you can see that it comes up. I'm just going to leave that up for you guys can see it. SM_cube.
Static mesh.
Sorry. That's the blend. There you go. Now you've got the naming convention: blueprint, static mesh, T for texture, SK for skeleton, and a bunch of other stuff. It's all like that in Unreal Engine. Okay?
Sorry, what's SM stand for?
Static mesh.
Okay.
Static mesh, right? There's also a skeletal mesh, SKM, right? Which is if you want to have a character, it's an SKM, skeletal mesh. Okay. But for now, we have this static mesh cube. We're going to click onto it, and when we do, I can scroll out because you can see that the static mesh that's been added in is this cube. One thing is, if we click away from the cube, the static mesh, and click back, there's a couple of other things that get enabled. One of them is the materials. So material, for those people who don't know, I want you to think about it as a program that basically applies a texture. And texture, remember we said game dev, textures mean images on an object. So a program that applies images to an object, to the surface of an object. There's different kinds of materials. In this case, it's a surface material that applies images to an object, right? So this material is called mi_prototype grid gray. And mi is actually not a material, it's a material instance. But for us, I just wanted to show you this because it's part of the static mesh. That's why it looks gray like this, okay? But we can make it other colors. And if you look through, if you actually just kind of pull this down, this materials tab right here, or this materials area, you can look, I can make it solid blue because you can see that there is an mi_solid blue color. So I can choose that color. And if you look through, there's other materials you can try as well. I'm going to choose mi solid blue because I want my cube to be blue, just like the other cubes we have in the game. Okay? What if I want to make it red? I can do that too by making a new material or changing the material instance. Okay? And we're going to talk about that later. Bear with me. Lots of stuff to show you today. So now that I've got this, I've got my cube mesh. I can compile and save. The top corner is very important. Compile and save. Always compile and save. Why is this? If you don't save and you compile and your Unreal Engine editor crashes, you've lost your work. So I want you to develop a workflow, my friends. Compile and save every single time you do something. This way, no problem.
Is there an autosave feature?
There
every
is,
5 minutes or something?
there is, but I recommend compile and save AIR.
Oh yeah, for sure. But is it set to every 5 minutes? Or
It's set to every 5. You can change the setting too, but it doesn't matter. It's still, you'll still lose your work.
Control S.
Yeah. Yes, it's also another way to do it. Control S will work, but definitely compile and save all the time. All right? All right, great. So now that we have this cube, notice if I go back to the content drawer by clicking on the tab, I can click on the blueprint, or I can click on the third-person perspective scene, right? Third-person map. I can go back and forth, and I can go, and all I can see now is I'm in my content drawer. Here's the cube. I can pull this cube into the game, the one I just made. So I can just take this cube, BP cube, and pull it in, right? And now I have my cube in the game. It doesn't do anything right now, but we're going to make it rotate. We're going to make it bob around. We're going to make it do stuff, right? Yeah.
If you doing this?
No, I'm not.
What do you mean?
I'm actually setting stuff again.
It depends on how you apply the material, is the answer. Right? And so, what are you applying the material to? Is it the instance of the cube itself, the BP underscore cube, or are you applying it to something else? Right? Because remember, whenever you pull in an object into the game, it's an instance object. It's a copy of the original, right?
Setting up the
When we're working in a blueprint, we're working on the original. Well, we could, depending on how you put it in. The answer is it's possible. Yes. Bear with me. If I play the game, you can see that there's another cube I've got here, but I can't move it anymore, right? I can't move it. Even though the cube, I just put this cube in the game, I can't do anything with it, right? This cube is not physics enabled. It's my cube. BP underscore cube I made, right? The other cubes, the blue cubes, are physics enabled cubes. They can fall. This one doesn't because I haven't made it that way. You have to tell the program what to do. Okay, there's nothing automatic in this program. You have to do it for yourself. Okay, let's go back to that blueprint for a second. So now that we have the shape of the cube we want and the color, that's nice. I want to do a couple of other things here in the viewport. One thing to note in the viewport is you have all the same controls you have in the main viewport. For example, I can still rotate the object here. So by default, I can change the rotation. I can change the scaling of my object here inside the viewport. And for every instance, every time I pull a cube inside of my cube, inside of the game, it'll retain all those things, all the changes you make here, okay? Because this is a blueprint, just like it is when we're creating a house. Once I make my blueprint and I pull it into the game, it becomes an instance, a copy of the original, over and over again, which is pretty cool. I can also scale the cube, and it'll scale all of the copies, okay? Now, one thing we want to do, so that's the anatomy of a blueprint in terms of a couple things. So the components tab is one thing. We also have the graphs area, functions, and variables. Okay, these are the areas on the left. This is where we actually do the programming part on the left, right? The event graph is where we have a couple of things. We can zoom in and zoom out on the event graph. The event graph is a grid, and this is where we do all of our programming, okay? The event graph has three things that it comes with by default, if you want to look at this, right? It has the event begin play, the event actor begin overlap, and the event tick. Those are the three things that all blueprints start off with by default, okay? The event begin play, anything that you attach to this node only triggers once. It's very similar to Unity's start function. If you ever program in Unity, it's like start in Unity, right? The event actor begin overlap is when something overlaps with your object, okay? That's what it is. For now, what I want you to do is I want you to left click and drag, highlight the actor begin overlap, and press delete. We can delete objects like this by default. The event tick is similar to Unity's update function, okay? So that's what it is. Event tick is just an update function. Everything you attach to the event tick triggers every frame, which means, for those people who don't know game language for frames, my friends, listen up for a second. Frames mean something that happens computationally every 1/60th of a second. All right, that means 60 times per second on average, right? I do some kind of computations and they take place if you connect something here, you know, in this tick. So things you can connect to tick are something that you want every frame or a bunch of times every second to loop. You want something to happen over and over again, you connect it to tick to your tick event. However, I want to warn you that the more stuff you connect to tick, the more computationally expensive your new blueprint is, because you're making it do stuff every frame, right? Every 60 times every second or higher, okay? So be careful with this one. These two things, although they look like just regular nodes, they're special nodes. Notice how they're red? They're kind of grayed out right now because I haven't used them. Red nodes are event nodes. That's what they are. Event nodes are something that are triggered depending on the time frame. So again, like I said, the event begin play is triggered at the beginning of play when you put the object, when the object starts in the game. So if that object lives in your world at the beginning of play, that event node is triggered, okay? Event tick is an event that triggers all the time when the game is inside the scene, okay? Or when the object is inside the game. So what we want right now is I want you to delete the event tick as well, okay? And I want to work with the event begin play. So event begin play allows us to start some stuff off. Let's do the first thing I want you to do. I want you to drag from this big pin here. Notice this big pin? I want you to drag from it. So if you drag from it, notice that you have this wire that comes out, and this wire gives you a bunch of different actions you can choose, okay? What I want you to do is I want you to drag out from the wire, and when this search field comes up, I want you to type in the word print. Okay? It'll come up with a bunch of options. One of them, the two most popular ones, will come up at the top. I want you to use print string. Left click on print string. Okay? When I do this, the event begin play is no longer grayed out. It's actually something that's in use right now for the first time. Okay, so notice that now I have a event begin play and I have this print string node. If I click this little down arrow, it expands, and I have some other controls I can set for the print string. Let's use our classic print string and change the value that's in this where it says in string over here. There's a value that says hello. If we click inside of there, and if I press comma after the hello space and then world with an exclamation mark, we have our hello world. Okay? Hello world, for those people who've never programmed before, is the classic way we start every programmer programming. Hello world. And it has to be just like this. Hello, comma, space, world, exclamation mark. That is the proper way of doing things. Classic, okay? Notice here the duration that this is going to show up in the game, because this is only going to trigger once, is 2 seconds. Let's change this duration to 30 seconds. Let's change the number from 2 to 30 and press enter. Okay? So if I have a cube that we just made in the game, right? When it's in the game, it's going to say hello world. Let's try this out. So compile and save. Go back to the level with a cube in the world that you dragged in from your BP underscore cube in your blueprints folder. You dragged it in, that's the assumption. Press play now, and you should see hello world on the top left corner. This is your first piece of code, my friends. If you've got hello world, congratulations, you've made a blueprint and you've got a little bit of functionality. You froze?
I froze.
Come on.
I was not lying.
Come on.
You got a frozen food? Possibly.
No, he's got frozen really?
Oh. That's fun. My cube was very advanced.
So advanced, yeah.
Ratchet.
Today we're going to all kind
It doesn't have to control S, control S, control S,
Yeah,
all the
yeah, I did not. I got that.
So did it show hello world? If you got that hello world,
All right, I'm on your.
you got your first piece of code, and the first time you've written something in Unreal Engine, believe it or not, it is code you've done. Did it come back?
Yeah, I'm just doing the close thing now.
All right. So let's go back to our blueprint. Let's continue. So now we've done this. Notice if I'm running the code and I go back to blueprints, I have this orange outline here that says simulating. Okay? You can stop it from here as well. You can press the stop button to stop, not just escape. If I press the stop button, it stops simulating. But notice that my play button is here, visible in the blueprint editor as well. Not just the regular editor in the level. This is the level editor. This is the blueprint editor, right? If I press play in the blueprint editor, it'll show us a little window here too. You can actually play the game here as well, all right? Now there's advantages to doing this. Going back to what you asked earlier, I'm not sure, you said multiple monitors. This is where multiple monitors come into play. Where you can simulate on one monitor, if you drag that simulation window on one monitor, it will remember, and then you can see what it's actually doing. You'll see the execution flow on the other screen, which is pretty cool. All right? So, so let's try this again. So if I press play here, it'll run, it'll say hello world on the left corner, and then if I press stop or escape, it'll stop. So what have we done here? We have our event. This is what started things. We have a wire we've dragged from this pin. This big white pin, I want you to think about this, my friends, as the execution pin. Every single time we have big white pins like this, these are execution pins. We have to connect all of our nodes together using execution pins for the most part in order for us to have something called execution flow. I want to flow from the left to the right, okay? If I don't have these pins connected, by the way, you can disconnect pins by using Alt and left click. That's a shortcut. Let's do that. Alt, left click disconnects the pin, right? Left click and drag connects the pin, all right? If I disconnect the pin and press start now I'm going to get nothing because guess what? Even though this node exists in the event graph, it's not connected to an execution pin, and so it will not trigger. You must have nodes connected to the execution pins at all times in order for you to make those nodes perform any behavior that you want. Make sense? Let's move on. So now that we have this, I want to do something more than just print something. This is our first node. We can delete nodes by pressing, highlighting a node by left-clicking it and then pressing the delete key. We can do that. Anytime you want a node, you can try right-clicking here as well, right? Right-clicking with no pin dragged will also do the same thing. I can also look for a print if I want to put it back, right? One good thing is it doesn't remember anything you did before, so it'll start from scratch. So it'll reset the node if you made a mistake. Okay, again, I can left click and delete, and I can delete nodes. So we know how to add nodes. We know how to delete nodes. I want to do this. Here's what I want to do now with my cube. If I want to rotate it, I want to rotate it in world space. Okay, and I want to rotate it around the z-axis. Okay, so the z-axis is looking down on the cube itself. That's where I want to rotate it. So I want to rotate it around the z-axis. Now you might be forgiven to think that you want to do this in the tick function, because the tick function, you could change the rotation every frame. Remember, it's computationally expensive to do this. We don't want to do it in the tick function. We have another thing we can use. We can use something called a timeline, which is really cool. Let's do this. So I want to right-click here, in anywhere in the thing, and if I type in the search bar, add timeline, you can see that it comes up with this little timeline option down here. I'm going to leave this up so you can see it. So I right-clicked, I want to add a timeline. Now this is a beautiful thing. If you're someone who's a math person, anyone a math person in this room? I'm a math person. If you're a math person, then you'll love this, because if I left-click the timeline, let's rename this timeline to rotate. We'll say rotate cube. We'll call it rotate cube. Okay? So a timeline is really cool because a timeline has a bunch of execution pins in it. Take a look. There's a bunch of stuff you can do, right? I can play from start, I can stop, I can do a bunch of stuff. But you're like, wait, how does a timeline help me? A timeline is one really special node that is configurable, right? Let's double click on the timeline. Are you ready? Let's double click on the timeline. If I double click on the timeline, it gets its own special graph, which is pretty cool. I want to add in a track. On the top left corner of the timeline, there is a track. I want to click onto it. And there's different kinds of tracks you can add. I want to add a float track. Let's add a float track, okay? Are you with me? When I add a float track, I get something really cool. Again, for those mathy people out there, I get a motion graph, which is pretty awesome, right? And what I want to do now is I want to rename this float track to something like rotation underscore Z. Let's call this rotation Z. And press enter. Anything I create, any float track, any track I make inside my timeline, the timeline becomes an output from my node in the future. We're going to see this in a second. So I've made a rotation Z, I've made a float track, right? What I want to do on the top, notice there's some options here. For example, the length of time, right? How long will this graph, how big in terms of timeline is this? It will last 5 seconds, all right? That's how long the time is. I want to choose this option here, which is loop. Let's choose this loop option up here on the top. Let's click this button. This means that the timeline will continue to loop forever. That's what it means, okay? Now, in order for my timeline to work, I need to give it some data points. Here's how it's going to work. At time 0, I want it to be at rotation 0. And at time 5 seconds, I want it to be at 360 degrees. Let's do that. So to do that, I want to right-click and add in a key. I'm just right-clicking on my timeline. I'm adding in a key, right? And I want to just, at the top here, with my key selected, I can choose the time, 0. And I can choose the value, which is 0. So 0, 0 is my first key. That means at time 0, I'm at 0 degrees, okay? I want to right-click again the second time, and I'm going to add another key in there. And this time, I want to change the time to 5 and my value to 360. Now, you can't see this value because it's way out of here, but take a look. There are these little controls here where I can zoom automatically. If I click this little zoom to fit horizontal, I can now see everything in 5 seconds. And if I click to zoom vertical, I can see now a little linear graph. If you're a math person, this is just a linear graph. It goes from 0 to 5 seconds, right? In a nice linear order. This is just how it is, okay? So now what we've said to this little timeline, we've kind of created these data points, a little graph, basically, that says, at time 0, it's going to be 0 degrees. At time 5, it's going to be at 360 degrees. Now, we need to use this timeline. Are you with me, by the way? Do you have this look right here? Timeline? Okay. You've got here 0. Oh, you did? Okay, so put in 5. What do you guys do? Okay, right click again. And add a key. And then, 5. Yeah. And it's already. All right, so now let's go to this. Click that little button. Click that button. Yeah, so there it is. Yeah, you get another one. So let's click on that one. Oh, no. Yeah, click it and then hit it. That one. with me? Are we all got those nodes? The timeline is done. Let's close down the timeline. We don't need the timeline anymore because we've done this. Let's close down this timeline, right? And then we have this new node, and take a look. It has rotation Z. You should have this new node. If we close down the timeline, back to the event graph, it has this rotation Z. Now this is if and only if you've named the float track properly. If you didn't name the float track, it's going to say float track or something else, right? So let's double click on here and notice the float track is here. You can right click and rename if you need to. Right click and rename this float track so that it says rotation underscore Z if you don't have that already, okay? You need to have that because we need this output. This output over a span of 5 seconds is going to change. It's going to give us output every second for 5 seconds where it's going to give us some new value. That's what it's going to do, all right? Now, what I want to do is I want to change the actor's rotation. This is an actor, that's what we have. We'll talk about different types in the future. But I want to change the actor's rotation. To do that, I want to say set, let's type this out, right click and type in set actor rotation. Set actor rotation. That's the other node. I haven't connected anything yet. We're going to do that in a second, but this is the new one. Now let's take a look at the nodes. We talked about this is the blueprint. Blueprints are made up of a bunch of nodes, right? But nodes have to be compatible. Inputs and outputs have to be compatible. The compatibility is based on the colors that you see and the data type, right? So example, this rotation Z we made is a float type and it's green. Do you see a green input here on the set actor rotation? There's no green input. That means I cannot do this. I can't put it on any one of these things. It won't allow me to connect this output. I need this output though because this is the new value. I'm going to get 0, 1, 2, 3, 4, all the way to 360, and it's going to loop, right? So how do I do this? Well, we have this new rotation over here, and this rotation is a rotator. Okay, without getting too mathy, a rotator is not a vector. It's actually a quaternion. So if anyone knows vectors, a vector has two things, position and direction, right? That's what a vector has, back to math, right? A quaternion isn't that. A quaternion is in three-dimensional space, I want to turn, right? I want to turn, I kind of do one of these, turn in three-dimensional space. It's like a vector, but specifically for turning. Instead of having X, Y, and Z, we have yaw, pitch, and roll, right? Yaw, pitch, roll, okay? That's what it does. So each one of those things, yaw, pitch, and roll, is a float. So wouldn't it be nice if we could break this rotator into a float? We can. If you right-click the node, here we go guys, please follow along. You're going to miss this. If you right-click this node, you can split the struct pin. If you split the struct pin on the rotator, it becomes 3 floating point values where we have yaw, pitch, and roll. Okay, X, Y, and Z. We don't care about the X and the Y, we only care about the Z. So let's drag that line from our timeline, the rotation Z track that we made, and connect it to our new rotation Z, like so. What this is basically saying is I'm going to set my actor's rotation to whatever I'm getting from the output from my graph. My graph is giving me values from 0 to 360, and I'm going to change my actor rotation every frame to that. But nothing is going to happen. How comes nothing's going to happen here yet? Yes?
You haven't set it to play.
Nope, that's not the only reason. What's the other reason? Why?
Connected to the cube.
I haven't connected the cube? No, the cube is connected. The execution pins are not connected. If I don't have my execution pins connected, nothing's going to happen. I need to connect all those execution pins. Let's do it. So I'm going to go from the event begin play to the play execution pin, from the update execution pin to this input execution pin on this actor rotation. And my friends, you now have the cube that's going to spin. Let's see if this works. Let's try playing it and see what happens. Now it's going to spin on the ground, right? And it's going to spin all over the place like this. Woohoo! Right? But it does work. Okay? Question for you guys. I'm going to ask you this question now. Why is it spinning on one of its parts and not on the middle. Yeah.
The anchor point was on the corner.
Wonderful. The anchor point is not in the right place. We can change the anchor point by moving the cube around inside of the viewport of the blueprint. Let's try this, okay? So if I go back to viewport, if I click on the cube mesh, you can see that the anchor point for the cube is on the corner. That's where it is, right? But we want to make it so that this thing rotates, you know, somewhere else. It rotates in the middle, right? So if I move this cube, let's say, you know, kind of in space a little bit, and if I press play again, is that going to make a difference? Well, it kind of does, but it kind of doesn't. And it's the nature of my cube. My cube, like you said, the anchor point is on the left, on the bottom, and this is what's doing it for me, right? So it doesn't matter where inside of my viewport I move it. I can move it in my viewport, but it's only going to rotate from there. We have no choice about that because that is where the cube is centered. We can't change the anchor point of the cube. That's been created for us. If I had Blender and I brought in a Blender cube in, and I can have the Blender, if that anchor point was in the middle of the cube, then it would be rotating from the middle of the cube. Okay, so that's how your cube should rotate, from the corner. Okay, that's okay for now. Well, what I want to do next is I want to make my cube bob up and down. How do I do this? Can anyone define? Like I've just taken you through one thing. I changed the rotation. What do I want to change next?
Location.
I want to change the location. I want to do the exact same thing with a new timeline, and I want to link it together with set actor location. Try it. Challenge. Try making it so that the cube goes up and down, right? From a starting value to an upper value and then down again. You're going to need 3 keys inside of this new timeline you're making. 3 keys. The starting location, the top of where it's going to go, and then where it goes back. Okay, you're going to have those 3 keys. Okay, you're going to make a track called, a flow track called location Z, because you just want it to go up and down. All right, that's what I want you to do. And I want you to do it so that in 2.5 seconds it's at the top, and at 5 seconds it's back down. So it's going to be 0, 2.5, and 5.
Okay.
Yeah.
Because I had to do a reboot, I'm not attached to the cube. So I've done things, but it doesn't really do it to the cube. So how do I get that?
Location set. Oh, it's connected to the cube. But maybe you didn't code the cube in.
That was the cube.
Save. Track. Let's take a look at rotate cube, rotation Z. This looks all good. It's rotating.
There you go. It's just not full.
Alright, don't need this anymore. Too bad. You lost your stuff. I know, I hate
So
that.
it does rotate through physics.
And then set rotation update. That shit looks good.
So if you pop that down, I think that's what's actually.
This is your cube, this big one?
Yeah. Here with the cube that's rotating. Rotating.
Cube mesh. Yeah, that's
Yeah,
cool.
I think that's what it was. I'm not 100% sure.
Big crap.
Tom,
Yeah.
did your cube simulate physics?
No.
No? Alright.
No. That's weird, man. Oh, yeah, serious. To be honest, that is weird. Let's do this. Let's,
There's a new one?
no, let's set blueprints.
He doesn't have that on
And let's try to. Okay, so it didn't work. Why? What did you do? It looks good. This is yeah, try it again. I mean, I don't know what you said.
Because that's selected. That
Doesn't matter.
references that.
No. This is for the entire object.
Okay.
Right, so I'm not sure what it is. It could be, what you could try doing is let's print out on update. This one's that you could do.
Yeah, so to confirm something is this is default.
Okay, so print out, let's see if we get any values.
Actually, useful to know for architecture.
Values is your turn.
Get rid of small values.
Yeah.
So it is rotating. Over 5 seconds. What's this going to? 0, 0, 0. Alright, that's important. And this one is going to be, no, that's the problem.
So it was moving, but agree.
So,
Why couldn't you do that?
well, because it's so small. Can't see that.
I guess there you go. For finishes, just like a little bit, and you start trying to get on.
So now we gotta get to go up and down.
Yeah, so your challenge is, for those people who are, your challenge is make it go up and down. I want you to add a new timeline and add, or just like we did this, we said set actor rotation. We want to set actor location. That's your challenge. Make it so that it goes up and down. So 2 new nodes, a new timeline node and set actor location. Let's see if you guys can do it. And I'm going to stop recording and I'll go around and I'll check to see if you guys can do this.